This is section 4.3 on logarithm functions. Get that to you. So we have 4.3, 7 to 51 odd. So here's on page 387. There's 7. Oops. 9 through 17, roughly. Page 388. And we're going to evaluate some logarithms. Every logarithm has a base. And we had to go up to 51, so I think I've shown that to you. Yeah, there you go. Okay, number 7, log base 8 of 8 equals 1. Write it without the log. So you start with the base, you go across the equal sign for the exponent, 8 to the 1, come back in for the result, 8. And log base 8 of 64 equals 2. Base is 8, exponent is 2, come back in for the result, 64. 8 to the 2/3 equals 4. Write it as a log. Write the word log. The base is 8. Exponent stands alone, 2/3, come back in for the result. So log base 8 of 4 equals 2/3. 8 cubed equals 512. Write it as a log. Log base 8. Okay, the exponent stands alone, so 3 goes here, 512 goes here. So log base 8 of 512 equals 3. Log base 8 of 1/8 equals -1. The base is 8, exponent is -1, come back in for the result, 1/8. 8 to the -2 equals 1/64. Write it as a log. Write the word log. Base is 8. Exponent all by itself, -2. 1/64 comes here. 9a, log base 3 of 81 equals 4. Write it without the log. Base is 3. Exponent, you go across the equal sign, 3 to the 4th. Come back in for the result, 81. 11b, log base 10 of 0.01 equals -2. Base is 10. Exponent is -2. Come back in for the result, 0.01. 15a, natural log of 5 equals 3y. Okay. E to the x and ln x are inverse functions of each other. So to get rid of an ln, you put an e down and sunken down over here. So these will cancel out, or 5 equals 3 to the e to the 3y, or e to the 3y equals 5. 17a, 10 to the 4th equals 10,000. Write as a log. So you write log, the base is 10. Exponent is 4. That's all by itself. The result is 10,000. So log base 10 of 10,000 equals 4. And the understanding is if you don't put the word, if you don't put any base, it is base 10. So log 10,000 means log base 10 of 10,000. Okay, so if you write a log equation and there's no base, it's understood to be 10. On your calculator, if you see log, that's base 10. You can't really forget it because above it, it says 10 to the x. Likewise, for a natural log, ln, you can't really forget what the base is because it says e right here. So log of 10,000, which I can do on my calculator, is equal to 4. So for instance, log 10,000, and there's 4. Okay, 8 to the -1 equals 1/8. Write it as a log. Log base 8, exponent is by itself, -1/8, -1 and 1/8 goes over here. 3 to the 5th power equals w. Write it as a log. Write the log. Base is 3, exponent is 5. Result is w, like so. Okay. For 23a, e to the x equals 2. The original, ignore the red. So to get rid of an e, you take a natural log of both sides. So ln and e cancel each other out, property of inverse functions. So x equals natural log of 2. 25a, log base 2 of 2. Call it x. I have it in red because that wasn't a part of the original problem. Unscramble it. 2 raised to the x power equals 2. So x is equal to 1. So that means whenever you see the same number here and here, that answer is 1. Log base b of b is equal to 1. Okay, log base 5 of 1. This was the original problem. Call it x. Unscramble it. Base is 5. Exponent is x. Come back in for the result of 1. And the answer is 0. Anything to the 0 is 1. So the log to any base of 1 is equal to 0. Log base 6 of 6 to the 5th power, can call it x. Write it without the log. 6 raised to the x equals 6 to the 5th. When you look at it like that, then x has to be 5. Log base 3 of 1 over 27, call it x. Unscramble it. 3 to the x equals 1 over 27, which is the same as 27 to the negative 1. 27 is 3 cubed. So 3 to the x equals, here's 27, 3 to the 3rd to the negative 1. That's 3 to the negative 3. 3 to the x equals 3 to the negative 3. So x is equal to negative 3. 31a, this is a property of inverse functions. 3 to the log base 3 of 5 is just going to be 5, not 3. It should be a 5 there. The 3 and the log base 3 will simply cancel out. Likewise, e to the ln 10, e and ln cancel each other out. The answer is just 10. 43b, log base x of 8 equals 3 halves. Base is x, exponent is 3 halves. Come back in for the 8. To get rid of 3 halves, you raise both sides to the 2/3 power. 8 to the 2/3 means cube root of 8, and then you square it. Cube root of 8 is 2. 2 squared is 4. 35a, log base 4 of x equals 3. 4 raised to the 3rd power equals x. So x is 4 times 4 times 4, 64. ln x equals 3. To get rid of an ln, you exponentiate, put the e down, sunken over here. So x is e cubed. Punch in a calculator, it's about 20.09. Let me show you quickly. Second function, e cubed, e to the 3rd power, 20.085, so 20.09 rounded off. Log base 10 of x equals negative 3. Unscramble it. 10 to the negative 3 equals x. So 10 to the negative 3 is 1 over 10 cubed. 1,000th is my answer. Okay, then try some logs. The log of 2 is 0.3010. So that's log. That's log right over here. Log 2, 0.3010. Log of 2/3. So log, log parentheses 2 divided by 3. Negative 0.17609. Negative 0.1761. Natural log of 25.3. So ln, that's a different button. The base is e. So what do I want? ln of 25.3. ln of 25.3. 3.2308. And ln of 1 plus radical 3. ln parentheses 1 plus second function square root of 3. Natural log of 1 plus square root of 3. 1.0051. Rounded off. Okay, then finally 51, a quick graph of 2 log x. Plug in 1, the log of 1 is 0. The log of 10 is 1. 1 times 2 is 2. Log of 100 is 2. 2 times 2 is 4. Log of 1/10 is negative 1 times 2 is negative 2. So log functions tend to look something like this, right? Okay, so that's section 4.3.